So in earlier classes, we have discussed about the relational operators that establish relationships among the values, right? So in this class, we talk about logical operators, right? The Boolean logical operators are or, and not, that refer to the ways these relationship among values can be connected, right? So Python provide three logical operators to combine the existing expressions. Fine. So Python provides provides three logical operators to combine existing expressions. Existing expressions. These are or, and 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 or, and not, right? So these are three. So this is one, this one is two, and this is number three. Okay. So these three operators are provided by the Python. Okay. So before we proceed to discuss the logical operators, right? So you have to know something about what do you mean by truth value? What do you mean by truth value or truth value testing? So this is what you have to know. So what is truth value testing? Because in some cases, because in some cases, logical operator logical operators base their results on truth value. Base their results on truth value testing. Fine. So let us discuss this topic, truth value testing, right? So Python associates every value type some truth value, that is the truthness. That is, Python internally categorize them as true or false, right? So any object can be tested for truth value. Okay, so let me write this. This is important. So Python associates Python associates with every value type. Type. Some truth value, some truth value, some truth value, or the truthness that is Python internally that is Python internally categorizes them as true or false or false. Any object can be tested. Object can be tested for truth value. For truth value, right? So Python consider the following values false, right? Python consider following values false, right? That is that is with the truth value as false. With truth value truth value as false. There are certain values which Python considered as false and true and true, right? So let me create a table to make you people understand what I'm saying. Okay. So let me insert a table. Let me insert over here. Okay. Okay. So here we write it down. Values with truth value as false. And here we write down values with truth value as true, right? So here the first thing is none. None is always considered as false, right? Then Boolean false, false. That is Boolean value false. This keyword is also considered as false. Boolean value false. Next thing is zero, zero, zero of any numeric type. Zero of any numeric, numeric type. So can you people tell me what are the two numeric types are available in Python? Please type on the chat window. What are the two numeric types are available in Python? Decimal. Yeah. Yeah. So the two numeric types are int and float, right? Perfect. So the two numeric types are int and float, right? So for example, 0, comma 0.0. Okay. For example, 0 or 0.0. So 0 is int and 0.0 is float, right? Okay. So next thing is any empty sequence, any empty sequence, any empty sequence, for example, For example, like the empty codes or empty tuples or empty list, right? Considered as false, right? So please note, note this is empty string. Please be muted, don't disturb. So empty string and empty string, and then this is empty tuple, empty tuple. Then this is and this is empty list, empty. Okay. So all these values are false. Okay. So any empty mapping, any empty empty mapping. So for example, mapping is dealing with the dictionaries, right? So I'll teach you all these chapters: string, tuple, list. These are one chapters, right? So I have given you a brief overview regarding string, but I have not done in detail the string. I will teach you the string in detail in future classes. So any empty mapping, right? For example, dictionary, that is a key value pair, for example, this, right, is also false, right? So here you can write simply, you can write over here simply, all other values are considered true. All other values are considered true. Considered true. Okay. So the result of the relational expression, the result of the relational expression can be true, can be true or false, can be true or false depending upon the values of its operand, the values of its operands, and the comparisons takes place, and the comparisons takes place, right? So do not confuse with the Boolean value true, false, and truth values. All right. So my point of teaching is this: okay, do not confuse between Boolean true Boolean values, true or false, true or false, true or false, and truth values, and truth values, truth values, right? That is the truthness of the value. Okay. Truth values. That is a truth. That is, you can say that, okay, truthness, Truth, truthiness truthiness values. True or false? True or false? Here you can see that I have written a small true and small false. Everything is small, but Boolean values are capital TRUE true and capital FALSE false. All right. So let me show you examples one by one. Right. Say say to avoid confusion. To avoid confusion. This confusion is a dangerous thing, right? So to avoid confusion, right, we shall be giving, we shall be giving truth values, right? Truth values, true and false, true and false, in small letter, in small letter, and with a subscript, and with a subscript, script, tval, right? Tval means truth value, right? That is, that is, that is what we can do. We can write here true, then here we write tval. That means that this is not exactly a Boolean truth value. This is a normal value, right? It's an object truthness or object falsiness is there. False, and this false is tval. Tval means truth value. This value is a truth value. Will be referring to, will be referring, will be referring to truth values of an object. Truth value of an object, of an object. Okay. So let me discuss some examples so that this theoretical concept will be clear to you people, right? So let me start my Python shell, and I will explain you. So the first thing is the first thing which I'm going to explain you, the OR operator, right? The OR operator. Please muted, please. Otherwise, I will throw you out from this session. Please be muted. Fine. The OR operator. Because in my other screen now, I can see you who is unmuting. So please, you people are literate people. So just follow my instruction. If you have any doubt, you just type it down. If you have any problem, just type it down. The recordings are available to you people. So please don't do this, right? So the OR operator. Fine. The OR operator combines two expressions which makes its operand, right? The OR operator, the OR operator combines two expressions. Again, yeah, subscript means ki Rishabh is asking regarding subscript. This is subscript. This one is called subscript. This one is called subscript, right? So I've written here clearly letters with a subscript tval, that is true tval or false tval, right? So this is subscript. So the OR operator combines two expressions which make its operand, which make its operands. The OR operator work in two ways. The OR operator works in these ways. Number one is the relational expression as operands. The relational expression as operands. And number two is the number or a string. Number or string or list as operands. As operands, right? So number one is relational expression as operands, right? Relational expression as operands. If you see the truth table of OR operator, it's very easy to understand, right? So the OR operator, first you understand this statement. The OR operator, the OR operator evaluates to true if either of its relational operator, relational operands, relational operands. Definition. I will clear all the doubts of means just when I will finish this teaching this topic, right? Don't worry if you people have any doubt. So the OR operator evaluates to true if either of its relational operands, that is example P greater than Q, or J is not equal to K, etc. I'm really sorry. Let me. I got disturbed. Let me complete this. The OR operator evaluates to true if either of its relational operands, either of the relational operands evaluates to either of the relational operands evaluates to true or false. If both operands evaluate to false. Okay. So there are two things here, x, y, and here if you write false, and here you write down x or y, so it will evaluate to false, right? False, true, it will evaluate to true, right? Because either right? Either of its relational operands evaluates to true. Okay, so this is true, false, then this is true, and this is true, and this one is also true, so this is true, right? So here you can understand that there might be some examples can be written like 4 equal to 4, or 5 equal to 8, right? If I write this expression, it will result you true. It will give you the result true, right? If I write this expression in the Python shell. If I write this expression in the Python shell that key 5 is greater than 8 or 5 is less than 2, it will give you false, right? So these are the simple examples. Okay, fine. So you have seen all these examples earlier also, and you have tested it also. Let me write it once, show you 4 equal to 4, 4 equal to 4, or 5 equal to 8. Okay, if you write this, it will give you true. And if you write 5 is greater than 8 or 5 is less than 2, you will get false. Okay, so these are the basic examples which I have done. Okay, so this is actually covering the relational expression as an operand, right? Because here we are using a relational operator to generate the result, right? So it is generating true or false, because here equal to this equal to and this equal to both are relational operator. This is also a relational operator. This greater than and the less than sign is also a relational operator. Fine. So these two are a relational operator, and they generates the result true or false. So this is the first part. Now let's discuss the second part, right? So first part we have a normalized thing, but the second part is here you can see a different kinds of results, right? So let me write this part. So number two is number. So when we compare numbers, string or list as operands. So today I'm not going to cover this list as operands. I will show you numbers and string, right? List as operands. Okay. So here, let me write down the statement. Oh, the statement is in an expression, x or y, if first operand that is expression x, that is expression x has false. Now I'm using t-val here, t-val, right? Has a false t-val, then return. See the statement here. If in an expression x or y, if the first operand has a false t-val, then return second operand y. Then it will return second operand y. Okay, as a result. Otherwise return x. Otherwise return x, right? So let me draw the truth table for this. This is special thing, right? The people who are coming from Java language, they don't have these things. Fine. So the people who are in new to Python, for them it is good, because the people who are coming from Java, they may get confused with this. right? So be careful. Okay, so what I'm saying right now, so x, y, and here I'm using t-val, right? That means ke truthness. So false t-val, and y is also false t-val, right? Then it will here, if it is written x or y, it will return y, right? So false t-val and then true t-val. So it will return you y. Then here true t-val, and here it is false t-val. So it will return you x. True t-val and true t-val. So it will return you x. All right. So let me explain you this process. All right. So if I write here 0 or 0, if I write here 0 or 0, what it will return, right? So first this is 0, that means okay, this is false t-val, this is false t-val, and this is also false t-val, right? So it will return you 0. Okay. So let me give a try here. Okay, how it is working, right? So let me try with the t-vals. So let me write here. Let me write here none. Or first write me 0, 0 or 0. So it will return you 0. You can see, right? If I write here 0 or 8, 0 or 8, right? It will. Let me write here none. Let me try with none. No, any none or 0. All right. So none is also false t-val. So it will return the 0. If I write here 0 or none, right? So it's not returning any value because none is nothing. It's returning none. It's returning none, right? Because none is nothing. Okay. So if I write here 0 or say 8, so it will return you 8. Fine, because it's following the truth table. Okay, if I write here hello, 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 or if I write here this empty string, then it will return you hello, right? And if I write here empty string or hello, it will return you hello. Okay, if I write here empty string or empty string, it will return you one empty string, right? Okay. So this is the thing. So here we are getting the values. Here we are getting the values. Fine. So if I write here 5.6 or 6.6, what will be the output? Please type on the chat window. What will be the output? Okay, 5.6. 5.6, correct? 5.6. Yeah. So everyone is correct this time, right? I hope you people have understood or you have a clear clarity regarding this. The truth value and Boolean true and false value. So these are treated differently in Python, right? The people who are coming from Java language, this is not the case. So it treats Boolean value separately. There is no concept of truth values, right? Fine. So I hope you people have understood this. Okay, so let me write another expression and you tell me the answer. If I'm writing here 20 greater than 10, or or I'm writing here a plus 1, a plus 1 greater than 1. right? So what will be the answer now? So please type on the chat window. So one person has answered true, another people, everyone has answered true. One person has answered T. Suvir has answered T. T means true, right? Okay. Yes. Okay. So Shayak has typed true. Uh, ah, so everyone has answered true. So let me execute this. Can you people type Y answered true? Yes, I got one answer. The first one is true. Okay. Since the first thing is true, true. Yeah. So basically, the first expression, that is 20 greater than 10, is true. Okay. So we'll get the answer true. If I reverse the expression, if I write this, a plus 1 plus 1 greater than 1. Now the fun will be there. Or 20 greater than 10. Now what will be the answer now? So Subhalakshmi is asking, will it show error? She's asking me. Rishabh, false or error? No, you should select one. You cannot select two. Uh, False. Okay, he selected false. Fine. Yeah, error. Error. Okay. 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 Error. As a string cannot be add to integer. Yes. Yes, Saini, the string cannot be added to integer. Add means ki you cannot concatenate a string with a string. You cannot concatenate integer with a string. So that is why it will produce an error, right? So you people are correct. So you have got the concept, I feel, right? So let me keep all these things in our notes so that it will help you out, right? And here it will be control V. Okay, so I hope or operator more or less idea is clear. If you face any issues, you can later on also you can talk to me, not a problem. Okay, so let me proceed with the next option called AND operator. Okay, so fine. So the AND operator, the AND operator. So AND operator also works in two ways: relational expression, relational expressions, expressions as operands, as operands. Fine. And number two is number or string, number or string or list as operands, as operands. Fine. So the theory regarding AND operator is, right? This is important. This line is important. The rule, right? The rule of the game is the AND operator, the AND operator, the AND operator evaluates to true, evaluates to true if both, if both of its relational, of its relational, if both of its relational keep all your doubts in your head. When I will say ask your doubt, then you will ask, not a problem. Okay, you write your doubt in your copy, and when I will say, then type it on the chat window. So the AND operator evaluates to true if both of its relational operands, both of the relational operands evaluate to true, evaluate to true, or false if either or both the operand, if either or both the operand, either or both the operand evaluates to false, evaluates to false, right? So this is a thing, and this is number one, relational expressions as an operand, right? For that, the game of the rule is this. Okay, so there are two operands x, y, and we have x or y, and we have x or y. So this one is false. This is false. So the result is false, right? This is false. This is false. This is false. This one is true. The result is false because both should evaluate to true, right? Both. Both of its relational operands evaluate to true. So false true is false. Then true false is also false, and true true is true only, right? So here also, if we does the same experiment like 4 double equal to 4, and we write 5 double equal to 8, right? So what will be the result? So the result will be false because first one is true, this one is true, this one is true, but this one is false. This one is false. This is true, but this one is false. So the result is false, right? So if you write this 5 is greater than 8, 5 is greater than 8, and 5 is greater than 2, right? So this is also false, right? This is also false, right? So let me give you another example. Say 8 is greater than 5 and 2 is less than 5. Okay, so this will be so this example results you true. Fine. Okay, fine. So these are very simple examples, and we can execute and see also. All right. So if you write here 5 double equal to 5 double equal to 5, and and I think I took 4, but anyhow 5 or 4 isn't matter. 5 equal to 5, and 8 equal to 4, right? So first one is true, but second one is false, so it will return you false, right? So if you write 5 is greater than 8 and 5 is less than 2, right? So 5 is greater than 8 is false. So result is false, right? So if you write here 8 greater than 5 and and if you write 2 less than 5, right? So the result is true. Evenly, you can assign the values into the variable also, like x equal to 10, y equal to 15, right? Oh, sorry. Y equal to 15. By mistake, I've given a space there. So y equal to 15. If you write x, you can see 10. If you write y, you can see 15. You declare another variable a equal to 5. Then you declare another variable b equal to 7, right? So now you write down a conditions like this, k x greater than y and a greater than b, right? It will return you false because the value of x is 10 and the value of y is 15, right? So 10 is greater than 15 is false. So let me do another experiment here. So let me make here a less than b, right? And x is less than y, right? Then you will get true, right? So you can do it in this way because originally when we write program, we deals with variable, not directly with the values, right? We never hard code values in our program. Okay, so this is how AND operator work with the relational expressions, right? So we can paste all these over here. And here I remove. Okay, you can keep it here because in Python indentation is very much important, right? So many people have asked me regarding this question, what is block, what is indentation? So in Python, indentation is very much important, right? As you experience with writing programs in Python, you will understand what you mean by indentation because you have to do it regularly. You have to indent your programs or indent your statements regularly. So you people can easily understand what do you mean by indentation, what do you mean by blocks, all right? It's very easy thing, don't worry. All right, fine. So this is the basic idea regarding the relational expression as operands, right? So let me do the next one, number 2. So number 2 is number strings for number strings and list as operands, as operands, right? So the rule of this game is in an expression, in an expression x and y first if first operand if first operand that is expression x, that is expression x has false t-val, right? Then return then return then return first operand x as a result, then return first operand x as a result, otherwise return y, otherwise return y. So this truth table is quite interesting, the people who are coming from Java background, all right? So x and y, and here we write it down. I have done a mistake here. It will be x and y, all right? By mistake, I've written or there. Okay. So X and Y, right? So here we have false T eval, and here we have false T eval, right? So we get here X, right? Here we have false T eval, and here we have true T eval. So here we get X. Here we have true T eval, right? And here we have false T eval. So it will return Y, right? So here it is true T eval, and here it is also true T eval. So it will return you Y. Okay, fine. So this is what the theory says. This is what the theory says, right? So in an expression, if X and Y, in an expression X and Y, if first operand, that is expression X, has a false T eval, then the first operand X as a result, right? It will return first operand X as a result. Otherwise, it will return Y. Okay. So if I write here 0 and 0, if I write here 0 and 0, so this will output you 0, right? If I write here 0 and 8, it will output you 0. Okay. If I write here 5.5 and 0, right? This will output you 0. Okay. If I write here hello and 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 empty string, right? So it will output you an empty string, right? If I write here empty string and a, it will output you empty string. If I write here empty string and empty string, it will output you empty string. If I write here a and j, it will output you j, right? Understood? So if I write here, so you can see that here in this case, this rule is followed. The first one is true. So this one is true. This one is true, but this one is false. But this one is false, right? So this one is true and this one is false. Let me use different color for this. Undo is not happening. Okay. Okay, finally it has happened. So this one is, yeah. So this one is, what happened? So this one is true and this is false. This one is false, right? And it is following this rule, right? So that is why the result is Y. That is why the result is Y. That is why the result is the second one, because first one is true. So it will check the second one, and second one is false. So it will return you that, right? So let me do all these experiments on the shell, right? On the Python shell, and we do. Okay. So we write here first is 0 and 0, right? I said 0. Okay. 0 and 8. It will return you 0, right? 5 and 5 and 0 0.0. So it will return you 0 0.0. Then if you write hello, if you write hello and you write this, it will return you the empty string, right? If you write empty string and empty string, right, it will return you empty string. If you write here A and J, it will return you J, right? Okay, because A is true value and J is also a true value, so it will return you the second operand as a value. So be careful when you are using the operand as a in the AND operator, right? So let me copy all these. Okay, and we paste it over here. So let me do one experiment after this. If I write this statement, right? If you remember where, yeah, this is statement. And here, instead of or, if I use and, if I use not this one, uh, not this one, yeah, this one has executed properly. Now, so if I use this over here and I change the or to and, then what output I will get? Okay, please type it on the chat window. So error, error. Yeah, two people have said error, error, error. Okay. Yeah, type error, correct. Type error. Fine. So basically it will give you error, right? It will give you an error because it will check the second statement also, because first statement is true. So it will check the second statement, right? Understood. So if first statement is true, then it will check the second statement, and second statement is having some issues, right? So it will generate an error. Okay. So be cautious when you are using OR operator. It will not check the second expression, right? So you have to perform test of your program for both the conditions. Otherwise, you may face trouble uh, in your app, right? Or in the program if you have submitted to your teacher or maybe your client. Okay. I hope and you people have understood, I think. So let me take this example also in our notes. So we, okay. So let me write here something called important. Important. So the the AND operator test the the second operand only if the the first operand is true. Otherwise, ignore it. Otherwise, ignore it. Fine. Even if the second operand is logically wrong, even if the second, even if the even if the second operand operand is logically wrong. Logically wrong, right? So if you write here 10 is greater than 20 and a plus 10 is less than 5, right? It will will result you false, because this condition is false. It will not check the next one, even it has some error, right? Understood? So the next operator is, I hope and is clear for everyone. So the next operator is the not operator. Okay. So the next operator is the not operator. The not operator. Fine. So the Boolean, logical not operator, the Boolean logical not operator works on works on single expression, expression or operand, operand. That is, it is a unary operator. It is a unary operator. Fine. The logical not operator, the logical not operator negates or reverses the truth value. Logical not operator negates or reverses the truth value of the expression. That expression, that is if the expression, if the expression if the expression is true or true well, then not expression is false. Then not expression is false. Expression is false. And vice versa. And vice versa. Right? So there is another important thing about not operator is that unlike, so you are imagining that if it is working with the truth value, what it will return. So unlike and or operators that can return that can return number that can return number or a string or a string or a list or a list, etc. Right? As a result, as a result, the not the not the not operator the not operator returns always a Boolean value, always a Boolean value, true or false, true or false. All right. So if you write here not 5, right? So let me do the experiment first and then. So if you write here not 5, it will return you false, right? If you write here not 0, it will return you true. If you write here not -4, what will be the output? Please type on the screen or chat window. Don't worry about notes. I will give you the PDF over here, so you will get it. Okay. So one person has typed false. Another one has typed false. Uh, Other people are taking rest. So two people are saying false. So okay, there's another person who also said it is false. Suvir has said false. Sayak has said false. Shuktika has said false. Okay, another person is typing. So basically the result is false because any non-zero value, remember this thing in Python, any non-zero value, right, is treated as true. Any non-zero value is treated as true in Python. And 0 is treated as false, right? So -4 is also a non-zero value. So it is a true value. It is a truth value. So the result will be false, all right? If you write here not 5 then 2, so this will return you true, all right? So basically it is negating the result. If you write not 5 is greater than 2, so it will return you false, right? So basically a not operator is negating the results. Fine. So this is a story behind the not operators. Let me move forward. Okay. Achha, there is one thing you noted down. Note is the operator not not has a has lower has a lower priority than than non-Boolean non-Boolean operators. So so not A equal to B is interpreted is interpreted interpreted as not A double equal to B. It means A double equal to B will evaluate it first and then not will be evaluated. Okay, understood. Fine. So, so this is the story behind not operator. Okay. So let me summarize it, whatever I taught you today. So let me create a table and summarize you. So, so first is operation. Operation, then result, and then notes. So operation is X or oh, X or Y. The result is if X is false, X is false, then return Y as a result, as a result, as a result. So here false is actually T-val, right? False is T-val. Okay. So then return Y as a result. Well, I will write it down later on. So, so if X is false, then return Y as a result, right? It or only evaluates a second argument if the first one, the first, if the first one is false, right? So let me increase the size of the table a bit. Okay. So next thing is X and Y. X and Y. X and Y. Okay. So if X is false, then so we'll write here T-val here. T-val. T-val means it's a truth value, right? We write it over here also. T-val. Write it over here also. T-val. T-val. Then X as a result. X as a result. Right. If or it and only evaluates, only evaluates, only evaluates the second argument, the second argument if the first one is true, if the first one is true, if the first one is true. The next is not X, not X. So if X is false, well, then return true as a result. A result as a result. Else not has lower priority, has than lower priority than non-Boolean Boolean operators. Operators, right? So this is a summary which I taught you. Okay, this is a summary table. You can say that. Okay, if you want to summarize whatever I taught you, so this is the following table. Following table summarizes the logical operator. The logical operators. So it's very important. You should understand the truth value and the Boolean true and false value. Okay. So next is the chained comparison operators, right? Next topic is chained comparison, comparison operators. So in Python, right? In Python, you can compare, right? You can compare variables or the values like this also. So you can write a statement like this, okay, 1 greater than 2 greater than 3 greater than 4, right? So this is not possible in Java, right? So here in Python we can change the comparison operators. So here it's returning me false because 1 is not greater than 2, right? 2 is not greater than 3 and 3 is not greater than 4. So it's returning me false, right? So if I write here 1 less than 2 less than 3 less than 4, right? Now it will return you true. But if you write here 1 is less than 2, but 2 is greater than 3, it will return you false, right? So it works. So chaining works here, right? Because here it means, let me write it down here. So here it means, so this statement is equivalent to 1 is greater than 2 and 2 is greater than 3 and 3 is greater than 4, right? So if you are coming from Java background, you will get astonished, ki, Arey, what statement we can write in Python. So Python is very much user friendly, right? So here this statement means 1 is less than 2 and 2 is less than 3 and 3 is less than 4, right? And this statement means 1 is less than 2 and 2 is greater than 3, right? So this is how we can change the comparison operators in Python, right? So this is also possible in Python. Fine. So the next topic which I want to discuss with you people is bitwise operators, right? Bitwise operators. Bitwise operators. Okay. So Python also provides another category of operators called bitwise operators, which is similar to logical operators, except they work on small scale, on binary representation of data, right? So let me write this note. So let me write two lines. Python also provides another category of operators, that is bitwise operators. Fine. Which is similar to the logical operators, except that they work on smaller scale, right? So on binary representation of data, on binary representation, binary representation of data, right? So binary operators are used to change individual bits in an operand. binary operators are used to change individual bits in an operand and an operand. Fine. So let me create a table to explain you the process. So insert, let me create the table over here. Insert table. So first is operator, operation, use and description. And 1, 2, 3, 4. 1, 2, 3, 4. Okay. So first is operator. Operator. Second one is operation. The third one is use and description. C-R-I-P-T-I, description. Right. The first operator is ampersand, that is AND operator. Right. So operation is bitwise, and so OP1, operand 1, and we'll write here and operand 2, that is OP2. Description. The AND operator, the AND operator, the AND operator compares two bits, two bits, and generates a result of 1 if both bits are 1. If both bits are 1. Otherwise it returns 0. Returns. Right. So let me increase the table size. So next is OR operator. This is bitwise OR operator. So you write here OP1 or OP2. The OR operator compares two bits, generates a result of 1. If the bits are complementary. If the bits are complementary. Otherwise it returns 0. Otherwise it returns 0. Okay. So next is the next operator is bitwise XOR operator. Bitwise XOR operator. So OP1 XOR OP2. Fine. The exclusive or XOR operator compares compares 2 bits and returns 1 if either of the bits are 1 and it gives 0 and it gives 0 if both the bits are if both the bits are 0 both the bits are 0 or 1. Fine. So the next operator is the complement operator, that is bit. This is bitwise complement. Bitwise complement. Bitwise complement operator. So it will be used like OP1 and the complement operator. The complement operator is used to invert all of the bits of the operand Fine. So let's examine one by one. All right, and I'll show you, okay, how it works. Okay. Yeah. So this is a table and we follow this table and we solve for one by one. Okay. So the first is bitwise the AND operator, right? So the bitwise AND operator, the bitwise AND operator, right? So here how it works. So it works like this: OP1, OP2, and we perform OP1 and OP2. All right. If the value is 0 and this value is 0, it will return you 0. If this is 0, this is 1, it will return you 0. If this is 1 and this one is 0, it will return you 0. If this is 1 and this is 1, then this will return you 1. Right? Let me show how it works. Right? See, for example, um, I hope everyone has idea regarding binary values, right? So for example, see, you take one very simple example. So you create, okay, you try to, there are systems, right? Systems used by computer, systems used by computer to perform calculations, right? So let me teach you that thing first. So number one is, so what system they uses? So they uses 8-bit system, right? 8-bit system. So if 8-bit system is not sufficient, then they uses 16-bit system, right? If 16-bit system is not sufficient, then they uses 32-bit system, right? And if 32-bit system is not sufficient, they uses 64-bit system, right? Understood. So for understanding purpose, right? If you understand this one, you will automatically understand the other, the other three, right? So if you understand this one properly, 8-bit system, then you will automatically understand all three. Okay. So how numbers are represented represented inside the memory, right? So for that, what you have to do, you have to create a group of switches, right? So 8-bit system, I'm talking about 8-bit system. 8-bit system means 8 switches are there. Okay, so let me create some space here. So let me create some space over here. So let me talk about 8-bit system. So 8-bit system, all right? It's very easy to represent a number in 8-bit system. Say for example, this is 8-bit system of the memory. So 4, 2, 2, this. So 0, 1, 2, 3, 4, 5, 6, and 7. Right? So this bit, right? This bit is reserved for sign bit. Reserved for sign bit, right? So if the value of this bit, right? If the value of this bit is 0, 0 means positive value, right? If the value of this bit is 1, it means negative value, right? So now we write down the values here. So we write here 1, 2, 4, 8, 16, right? 32, okay, 64, and this is minus 128, right? Be careful. I've said this is minus 128. Okay. So say for example, you remember all these values. Say for example, you want to create a number 79, right? So what are the switches you need to switch it on, right? So all these are switches. All these are switches, and switches have two values. Right? Either they can be off or on, right? So off means 0 and on means 1, right? So to create 79, we need to switch on some switches, right? So we are switching on, let's say 64, right? So 64 plus 32 will make more than 79. So we will not switch on this switch, right? 64 plus 16 makes 80. So we will not switch on this switch, right? 64 plus 8 is 72. 72 plus 4 is 76, plus 2 is 78, and plus 1 is 79, right? So this is a binary value represented inside the memory, right? So now you want to see, okay, sir, whether whatever you are saying it's correct or not, right? You should verify with the computer, right? I may be wrong. So what you have to do, you go to the Python shell, and Python shell will help you out regarding this, right? So what you do, you type just bin, and you put here, and you put down your value here, 79, right? And you press enter key. Now you can see the value here, right? You see the value, how many, you see the value, which is represented like this. Okay. So let's come back to OneNote and Control V. So this here, it is binary value is always preceded by 0b in Python, right? Binary value is always preceded by 0b in Python, which we have studied earlier, right? In our previous classes. So now you can see this value, right? It is 1. This 1 is matched. This 0. The 0 is matched. This 0. The 0 is matched. This 1. This 1 is matched. This one is matched, this one, and this one is matched. So this one and this one is matched. So my calculation is correct, right? So this is the way we represent the binary numbers, all right? So you need to understand this system called 8-bit system, right? Say for example, if we want to represent minus 79, right? So what to do with that one, right? So again, let me draw this to represent minus 79. So So 1, 2, 4, 8, 16, 32, 64. So these are the value which is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and 2 to the power of 6, right? And here you are getting minus 128, right? Now you have to design minus 79. So you switch on this switch because this is representing a negative number. So you got minus 128, right? If you select this switch, right, it will calculate as minus 64. So we will not select this switch, right? We will select this one, right? So this will represent minus of 96, minus of 96, right? And if we select this one, it will represent minus of 80. And now we select this one. So this will represent minus of 79. So this is how you can write the negative values you can convert the negative binary very fast, right? If you know this technique, right? So this is the way if you are appearing for gate examination and they will give you the numbers like this, then you can do it very fast, right? So this is a technique out there, right? So this is how you can represent the negative values. Okay. So this is representing minus 79, right? So if you go to Python, it will give you the 2's complement value of 79. Okay, so let me execute this and we check what is the value of minus 79. So we write here bin of minus 79. Okay, so it's giving you the value, this value. Shift home and let's check it, right? So it has given you the complemented value, right? It has given you the complemented value. Okay, what it does now, okay, it has given you 79 and it put the minus sign in front of it, right? So what we have to do, we have to complement it because this value and this value is the same value. This value and this value is the same value. And Python puts a minus sign here. Python puts a minus sign. So minus 79 is represented in Python like this. So Python is giving you the same value so people will not get confused. But actually in memory, it will be represented like this. It will be represented like this. So this is called 2's complement value. 2's complement value. Value, right? Okay, so I hope you people have a bit idea regarding the 8-bit system, correct? So if you have any doubt, you can type it on the chat window so that I can answer it. So you are asking that uh, you are asking that y64 Amrita is asking that y64 is 0, right? So let me do the calculations here, which I have done it orally, right? So if you write here, if you select this minus 128, if I select 64 now, it will become minus 64, right? If you write 128 plus 64, if you put 1 here, that means it will become 64, right? But this result you minus 64. I need minus 79. I need minus 79. Then what I will do, I will not select the 64, right? So I will write here 32. So you write here plus just a minute. You write here plus 32. Okay. So you write here plus 32 plus 16 and plus 1, right? If you do this calculation, you will get minus 79. So this binary value actually represents minus 17, right? I hope idea is clear now, how to represent the negative numbers. Okay. So if anyone wants to leave, he or she can leave. All right. No problem for me. They can see the recording. Okay. Uh, so let's move to the AND. So how AND will work? Okay. So let me select. So you always think about some switches, right? So say for example, this is another group of switch, right? So it's 1, 2, 4, 8. You remember this, right? So by using these switches, you can represent values from 0 to 15 in binary form, right? So if you write here 1, 0, 1, 0, right? It means it is representing 10. It is representing 10, right? So you can think about this. Okay, 1, 2, 4, 8, right? If you write all 0, right, the value is 0. If you write a 1 over here, the value is 1. If you write 1 over here and the value is 2, right? So in this way it works. Sorry, why the screen is on? Okay. So it works, right? So if you write here 0, 0, 1, 1, 1, 1 means 2 plus 1, it will give you 3. If you want to represent 4, you switch on this switch, you switch off all the switches, it will represent 4. If you want 5, you switch on 4 and 1, it will make you 5, right? If you need 6, so you write 0, 1, 1, 0. So this is 6, right? If you want 7, 1, 1, 1, it will give you 7. If you write, if you need 8, right, this will give you 8, right? So in this way, if you write all the things, if you write 1, 1, 1, if you switch on all the switches, you will get 15, right? So let me do some operation using AND operator, right? So for example, I want to know what is 12 and 10, right? If I write this on the Python shell, what it will give. So 12's binary is what? All right. So 8 plus 4 is 12. So I put 1, 1 and 2 zeros. This is the 12th binary. What will be the binary value of 10? So binary value of 10 will be 1, 0, 1, 0. And if we perform AND over here, right? So we have to follow this rule, right? So we have to follow this rule. The rule of AND is the AND operator compares. The AND operator compares the two bits and generates a result 1 if both the bits are 1, right? If both the bits are 1, then it will generate 1. So here you can see that okay, in this situation, both the bits are 1. So here it will generate 1 and other it will be 0, right? So now it will return me 8 here. If I write 12 and 10, it will return me 8. So let me write this in Python and see what Python is giving to us. Okay. So if you write here 12 and 10, all right. So now you can see it is 8. Okay. If you can do you can write here 10 and 12 also. It will give you the same result, 8, because it is doing internally the binary operation, right? And if you want, you can see the binary value of 8 also. Binary of 8. You can see that it is the binary of 8, right? So I hope you have understood this and okay, Control V. You can perform binary operation of any two values. So you can store the values into the variable also. Like say for example, you have stored x is equal to 67 and y is equal to 75 and 75, and you want to do x and y, right? So it will generate a value. Say it has generated 75. Okay. Oh, I have used, which operator I have used by mistake? So I have used here logical operator. So I have to use bitwise operator, X, and that is why it has given me 75, X and Y. I have to use this. So by mistake, I've used the logical operator. So X and Y. So now it's giving me 67. So let's calculate why it is giving 67. Okay. So let's go back to this. So the value of X is, uh, I took 67 and the value of Y is 75, right? So we write this 1, 2, 4, 8, 16, 32, 64, and we don't have minus, right? So we have values like 67 and 75. So we can design it by using these, right? So I need to design 67. So 64 plus 266 plus 167. So this is a binary value of 67. Now I have to design 75. So 64 plus 872, 74, 75, and rest I will put 0. Now I will perform, now what I will do, I will perform the AND operation, right? So these two are 1, so here I will put 1. These two are 1, I will put 1 here. This is 0, this is 0, this is 0, this is 0, and this is 1. So you can see that case 64 plus 266 plus 167. So it will return you 67, right? It will return you. So the result will be 67. If you write, if you declare this, and if you write here X and Y, it will return you 67. So I hope you people have understood the AND operator, right? So next thing is OR operator. Okay. So the inclusive OR operator. The inclusive OR operator. OR operator. Fine. The inclusive OR operator. So here, the rule is when both the operands are number, when both of its operand are numbers, the OR operator, the or you can write the OR operator. This is OR operator, right? The pipe symbol which is present before the enter key, right? Operator performs the inclusive OR operation right? So the inclusive OR means the inclusive OR means if either of the two bits I've written this already. Sorry, okay, let me write it down. Either of the two bits is 1. The result is 1. The result is 1, right? So we can see the OP1 and OP2 and OP1 or OP2, right? So first one is 0, second one is 0, the result is 0, 0, 1, 1, 1, 0 is 1, 1, 1 is 1, right? So this is OR operator, okay? So if you write here, say the value of, say we want to perform the OR operation between uh, 12 and 10, 12 and 10, then what will be the result? So 12 is 1, 1, 0, 0, and 10 is 1, 0, 1, 0. So if we are performing OR operation, so 0, so this one is 1, so 1. This one is 1, so 1. So this one is 1, so 1. So if we are performing OR operation, we will get, so 8, 4, 2, 1. So the result will be 14. So here we will get 14, right? So here we get 14. Fine. So the result will be 14. So sorry, extremely sorry. I have written here and this will be OR. This will be OR 12 or 10. So result will be 14. So if you write here, right here 12 or 10. So the result is 14, right? This is from Python. So it has the proof out there. So you can put it here, Control V. So it's copied from Python. Oh, sorry. Which one is copied? I copied this one. Maybe it has. Oh. So now you can see that K 12 and 10, the result is 14. So 14 binary is 1110, right? So this is the OR operator. So next is the exclusive OR operator. So let me do the exclusive OR operator. Exclusive or we can say it XOR operator. Right? The rule is this, the rule is pretty simple over here. The rule is the exclusive OR operator compares the two bits and returns. It compares the two bits and returns 1 if either of the bits are 1, and it gives 0 if both the bits are 1 or 0. So let me copy this rule over here, right? So okay, and let me draw the truth table, right? So operand 1, operand 2, and operand 1 exclusive or operand 2, right? So if you write here 0, 0, the result is 0. If you write 0, 1, the result is 1. If you write 1, 0, the result is 1. If you write 1, 1, the result is 0. So according to the rule of the game, you have to draw the truth table. Fine. So let me do the experiment here. So if we take 12 exclusive or 10, what will be my output? So 12 is 1100 and 10 is 1010. So if we are doing exclusive or, so this is 0, this one is 1, this one is 1, and this one is 0. So your output will be 6. So I'm sorry. The output will be 6. So we go to the Python shell and check it out. So we write here 12. We write here 12. We write here 12 exclusive or 10. Now you can see the result, it's 6. Okay. You can put it over here. Okay. So this is the story behind exclusive or. Fine. Now the complement operator. So complement operator complements the result, right? So the next operator is, the complement operator. So this is the complement operator, right? And we know the definition. I have already given it to you. So we go back here, and this is a complement operator, and it inverts all the bits, right? we come down. Okay, so we paste it over here. So this is a complement operator. So let me draw the table for this. So it works on only one operand, so OP1, and the complement of OP1. So complement of OP1. If you put here 0, you will get 1. And if you put here 1, you will get 0. So this is the truth table of thing, right? So if you write here complement of 12, if you write here complement of 12, so it will generate 1 1 0 0, so you will get 0 0 1 1. So 0 0 1 1 results 3, right? So your output is 3, right? So we'll take another example here. If you write complement of 10, if you write complement of 10, complement of 10, right? So 10 is 1 0 1 0, right? So 0 1 0 1. So this result is 5. Okay. So complement of 10 is 5. So we put here 5. So let's go back to Python and we try this out also. So complement of 10 will give you, oh, it's giving minus 11. That's interesting. Let me write complement of 12. Complement of 12. It's giving minus 13, right? So why it's giving minus 10, minus 11 or minus 13? So let me do the research work over here. So let's select this as 8-bit system. Let's do it with 8-bit system. So in 8-bit system, 0 0 0 4 zeros and 4 ones are there. Right? So this is an 8-bit system, right? 4 plus 4. So if I do the complement here, if I do the complement, this will become 1, right? This will become 1, this will become 1, this will become 1, this will become 0, this will become 0, this will become 1, and this will become 1, right? So this is sign bit, right? This is minus 128. So this one is 64, this one is 32, this one is 16, this is 0, so I will not take it. 0, I will not take it. This is 2 and this is 1. So let's calculate this properly. So minus 128 plus 64 is minus 64. Minus 64 plus 32 is minus 32. Minus 32 plus 16 is minus of 16, right? And minus of 16 plus of 2. So minus of 14, and minus of 14 plus 1 will make minus of 13, right? So we got here minus of 13, right? Got it? So this is how it works. Okay. So if you do complement, because I said na, it uses 8-bit system, 16-bit system. So it is using the 8-bit system. So that is why the result is minus 13. It will not be 3. It will be minus 13. Actually, in a flow, I calculated this because I was in hurry. So I calculated this, so this has gone wrong, right? So minus 10 will become minus 11. How it will be minus 11? If you use 8-bit system, because computer is using 8-bit system, 16-bit system, 32-bit system, and 64-bit system, right? So it shifts the system according to our need, or according to the number which we gives, right? So 10 is 1010. 1010, right? So if we complement this, we get 1 1 1 1 0 1 0 1, right? So if you calculate this, you will get minus 128 plus 64 plus 32 plus 16 plus this is 1 2 4, right? So this is what you will get. So minus 128 plus 64 is minus 1 minus 64 minus 32 minus 16. So minus 16 plus 4 is minus 12, and minus 12 plus 1 is minus 11. So you are getting minus 11, right? So when I have given here complement of 10, it has given me minus 11, right? So let's copy this results, and I hope you people have understood the complement operator and how it works with the computing system, right? So Control V, right? So this is how it is being done. All right. So here I'm using 4-bit system. This is 4-bit system, and this 4-bit system is deprecated in 1970. Is deprecated in 1970. But as for explanation purpose, the 4-bit system is easier, so I was using it. But computer is using 8-bit system, so we are getting these results, right? So I hope you people have understood and have the clear clarity regarding all the operators, right? So in the next class, I will be doing with something called operator precedence. Operator. Wait. In the next class, I will be doing operator precedence. In the next class, I will be doing operator precedence. This class will happen on next Sunday, right? So in this class, the next Sunday's class, I will be doing operators precedence, right? I will be doing operator associativity, right? And I will be explaining you something called expressions, how expressions, right? So you have some arithmetical expression, relational expressions, right? And then we study how to evaluate expressions, right? And um, we study evaluation of all types of expressions, and we study called Python data conversion also. We study Python data conversions, data conversions, right? And we study Python typecasting, right? Okay. And if we get more time, if I get more time, I will start teaching you some standard library modules of Python. I will do some standard library modules of Python. Modules of Python, right? Okay, guys, if you have any doubt, you can ask me. Okay. So now I'm stopping the recording here, and